Nomenclature for ketones. Very similar to that for aldehydes. Name the parent chain. The parent chain has to include the carbon of the carbonyl group. Now we're going to take the E ending off, and instead of al for aldehyde, we're going to put one, which is the last part of ketone. Again, numbering the chain so that that carbonyl carbon gets the lowest number. Here we do have to include the number because the carbonyl group is going to be in the middle somewhere. It can be in various places, so we have to indicate it. Then we put the substituents in front. If we have cyclic ketones, this is not a ring attached to a ketone. This is a ketone attached directly to the ring. Then that group is, with the carbonyl group, is number 1. So let's look at some examples. So this one is a line angle drawing. So we've got 1, 2, 3, 4, 5, 6 carbons. It's a nice straight chain there. 6 is hexane. So this is a ketone. This is hexanone. Hexane becomes hexanone. And then we have to indicate where it is. So numbering it for the lowest would be 1, 2, 3, 4, 5, 6. So this is 2 hexanone. Any questions? Here's another one. Condensed structural formula. So here's our carbon chain. And remember, you always have to consider that the longest chain might not be shown to you in a straight line like that. So this is 1, 2, 3, 4, 5 carbons, and no matter how we count, this is the longest chain that includes this carbon. So 5 carbons would be pentane, pentanone. And the position of the ketone group comes right before pentanone. So that's going to be on carbon number 3, no matter what direction we number. 1, 2, 3, 4, 5. So 3 pentanone, but then we have a couple of substituents. We've got one here and one there. 2 methyl groups. So that's dimethyl. Let's try writing backwards this time. And those are on carbons 2 and 4. 2, 4, dimethyl, 3, pentanone. The IUPAC names are very descriptive, but they sometimes get rather long. So what's this first one here? Looks like a box with a lever coming out of it or something. Well, what's the name of this guy? No. This guy right here, what's that? Yeah, that's 4 carbons, so it's butane, which would become butanone, but it's in a ring, so it's cyclobutanone. We don't have to indicate where that carbonyl group is, because if we needed numbers, that would be number 1. So we don't have to put the number 1. Letter D, we have 2 different functional groups here, don't we? Here we have the carbonyl group making it a ketone, and here we have an alcohol. Which one is more important? The ketone. So we're going to name this as a ketone. So this right here is cyclohexane. So that would be cyclohexanone. Cyclohexanone. We have to number this with this carbonyl carbon being number 1. We can choose to go either way. If we go counterclockwise, we'll get, this is 1, 2, 3, we'll get 4 and 5 for our substituents. If we go this way, we'll get 1, 2, 3, and 4. So that's better. We want to do it that way. So this is hydroxy, and this is methyl. Hydroxy comes first in the alphabet, so we're going to name that one first. So this will be 3-hydroxy 4-methyl cyclohexanone. One of the things you'll be able to do, which may or may not be useful to you, is you will be able to read ingredients lists and amaze your friends. It's like, especially on shampoo and cosmetic products and things, there's all these long, crazy looking names, right? That if you don't know anything about organic chemistry, how do you pronounce those things? But I dare you, go home and look at your bottle of shampoo, and I bet you're going to recognize some of these prefixes. And it's just, we just say the prefixes, one and suffixes, one after the other, and we can just pronounce the whole silly thing. 3-hydroxy 4-methyl cyclohexanone. This sounds very impressive. So, aldehyde functional group has precedence over ketones. Don't ask me why, it just does. So what do you do if you have both? And here's an example. Here's the aldehyde group, and here's the ketone group. We're going to name it as an aldehyde. So then how do we indicate this? We indicate that as oxo. So the longest chain here, we're going to start with the aldehyde group. Let's number that. This is 1, 2, 3, 4, 5. So it's based on pentane. The aldehyde group makes it pentanal. And then we've got this guy on carbon number 4. So we call that 4-oxopentanal. So it is a ketone, but the aldehyde's more important. This oxo prefix makes sense to me because we're kind of ignoring the fact that it's a ketone, and we've got an oxygen stuck on there. So it's oxo, not oxy, oxo, 4-oxopentanal. That's not going to come up real often. Any questions? Common names, of course. So for the ketones, these end up being a little bit like the ether names, where we name the groups attached to the carbonyl group. So looking at this one, there's the carbonyl group, makes it a ketone. What do we have attached to it? There's a methyl group here and an ethyl group there. So we name this ethyl-methyl ketone in alphabetical order. This carbon doesn't technically play in with either of these, but it gets in as the ketone. So we're saying here's the ketone group, what's attached to it? Here's cyclohexyl ethyl ketone. This is cyclohexane. As a group, it's called cyclohexyl. That's attached to one side of this, and ethyl is on the other. Cyclohexyl comes first. Cyclohexyl ethyl ketone. Here's one, we got a methyl group and an isopropyl group. Isopropyl methyl ketone. Then there are 3 that have extra special names. And so these ketones, a lot of them are going to be 3 words. Some of them may be 2. If you had the same group, you could call this dimethyl ketone, like this guy down here, dimethyl ketone. But this guy is so special that he's got his own name. It's called acetone. So acetone, and this is acetophenone, which would be methylphenylketone. So this is like acetone with a phenyl group on it. There, my pointer got stuck. And this is benzophenone, or diphenylketone. You should know what acetone is. These other two, I won't test you on those, but know what acetone is. It's just so common. It's the same as dimethylketone. What would the IUPAC name for acetone be? Because both acetone and dimethylketone are common names. It's 3 carbons, right? So propanone, and the ketone group is on carbon number 2. So I think we would call that 2-propanone. Although again, I'm not sure about the 2 if we actually need that, because you couldn't have a ketone with the ketone group anywhere else.